All right, this is just a quick little video showing you an alternate version of how you could have solved example 6. All right, the question was still that they wanted us to prove that 3 to the n power is greater than 1 plus 2n for all integers bigger than 1. Again, my first step, I still just sub in my first case when n equals 2, because that's the first integer bigger than 1. Do the algebra to show that it's true. It still is. Step 2 is, again, my statement, assuming that my statement is all true, except change all the n's to k's. Again, k is everything bigger than 1. Now, instead of changing my k's to k plus 1s and then doing the algebra until I argue that I know I have something that must be true, here I'm going to start with what I had originally and do the algebra until I can get both of those original k's to be k plus 1s. So, from the original statement, I am allowed to multiply both sides by 3. That's okay. On my left, 3 times 3 to the k is 3 to the k plus 1. So here I have a k plus 1 where there was originally a k. Left side is good. Now I just have to change the right side. The 3 can distribute into the square brackets, gives me a 6k plus 3. And once again, like a few videos ago, I'm going to do a sneaky math trick and introduce an extra term on the far side of this inequality, an extra inequality, and get something that's even smaller than what I have here. So 2k plus 3 does have to be even smaller than 6k plus 3 because 6k is bigger than 2k, and k was, remember, any positive number bigger than 1. Right, so 6k does have to be bigger than 2k. The 3's are the same. So this part on the far right is the smallest. The 3 to the k plus 1 is the biggest. So I can drop the middle part out and just say that the left side is bigger than the right side, the far right side. Now, I can separate this 3 into a 2 plus 1, which the 2 can factor out of the 2k plus the 2 to be that 2 times k plus 1. The plus 1 at the very end is still there. Now I have what I need. On the far left, it looks like a k plus 1 is the place where I originally had just a k, just an n. And on the far right, the k plus 1 is where I used to have a k, just an n. So I can replace those k's with n, the k plus 1s with n. So once again, if this is true when n equals k and when n equals k plus 1, then by the principle of mathematical induction, my 3 to the n power does have to be greater than 1 plus 2n for all integers bigger than 1.